for Skyping in. You just don't know from a teacher's aspect. It's a whole lot easier to teach to a couple of people rather than teach to 0 people, because subconsciously you know there's nobody there listening. You don't do as good a job as you would if 1 or 2 people are listening. So it does help to have, somebody listening. So thank you for both for continuing to Skype in. All right, I believe this one, I haven't seen this one, so I'll go ahead and click on it. This is 6.2, 31/11. 6.2, 31/11. And please speak up if there's any that you see in, or that you remember in 6.1, 6.2, 7.1, or 7.2. I've already went over a lot of these between 120.10 and 120.23. I've gone over just about all of these, except I hadn't went over that one because I think that one came in last night or Wednesday. So I'll do that one next, 7.2. Y'all should be able to see my screen. I hope you can. All right, so there is number 11. And first of all, let's see if it's a test question. No, it is not. Well, yes and no. I'm not going to ask you to do this, okay? But I will ask you to do everything after that. So let's go ahead and do this. We've got to do NPX. And so I'm going to pull up my handy dandy calculator. And I'm just going to move it over to the side a little bit. So I need y'all to do it with me so I don't make a mistake. Clear, and I am recording. All right, how do I know it's NPX? Well, because they give you NP and here's X. So whenever you see N and P together like that, they're either going to ask you for the probabilities or they're going to ask you for the mean and the standard deviation. This question asks both. That's why I say it's a good question, but just this part right here, I don't think I will ask you this. If I do ask you this on a test, it won't be 9. It will be like 4 or 3. Okay? So let's go ahead and pull up second vars. And with 0, you want to do normal CDF, and then after that, you do PDF. For 0, you have to do normal CDF because it doesn't work real good when you, not binomial, I'm sorry. Second vars, binomial. Pull up the CDF for 0 because it does better with cumulative. I can't get this thing to work. There we go. CDF is usually cumulative, but I tried to do it with binomial CDF yesterday and it wouldn't work, so I'm going to try it again today. See, it does. Okay, now we're still doing the normal. Let me hit second quit. This calculator, sometimes it goes quirky on me. All right, second vars. Binomial. I'm going to try PDF again. Yesterday I tried it and it didn't work. Okay, now today it's working. Don't ask. All right, so N is 9. P is 0.75. And X value is 0. And paste. Now I'm not doing this every time. I'll show you. I'm just going to use, so there we go. So you need to put point, oh God, that's 0. It says round to 4 places. You got 5 zeros because that's a -6. So you got 5 zeros. So that first one is 0, 0, 0, 0. 0.0000. All right, now I'm going to go back to, and I'm just going to type in second, enter. And now I'm going to change this to 1. And that's going to be 3 zeros, 0.0001, 2, and second, enter. Y'all do this with me if you're not. 2, 0.0012, 3, and see, this is why I don't put this on the test, because it does take up a lot of time to do 9, 3, but I'm doing it today because this is a good review question for the test, because it has 4 different type questions on it for the test. 0087, 0.0087, and y'all check with me, make sure I don't mess up a decimal. Second, enter, and 4, and 0.0389, and 5, and 0.1168, and 6, .2336, and 7, and that's 0.3003, and 8, .2253, and then 9. .0751, and let's hit check answer. It's a miracle. All right, now that is a test question, because I would give you maybe up to 3 or 4, something like that, and you would just type in MP0, MP1, MP3, MP2, MP3. I might give you one that's up to 3 or 4, okay, but I'm not going to give you one that's up to 9. All right, another test question. I might give you this, and you give me the mean and the standard deviation. So now I'm going to pull up the spreadsheet. And you can do it on your calculator, but it takes me too much time with this mouse and that calculator the way it's acting. So I'm going to do it on the spreadsheet. Okay, that's the 3rd explosion I've heard outside my house. I guess it's the city police department doing explosives. We have a city firing range near my house. Well, it's right beside my house, technically. Evidently, they're blowing up some stuff. Okay, so, and I'm going to make this big for you. Things I do for y'all. Let's make it and let's blow it out a little bit and down a little bit. There we go. All right, so I'm going to make it a little bit smaller so I can see the numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0.0000, 0.0001, 0.010012. Y'all make sure I got everything in there. 0.0087, 0.0389, 0.1168, 0.2336, 0.3003, 0.2253, and 0.0751. Now just to check, make sure I don't have something wrong, I'm going to do a sum, and that's equal to 1. So I know either by coincidence I've got a 1 or I've got everything typed in correctly. All right, so I got to find my mean and my standard deviation. My mean is equal to the summation of x times p of x. That's my mean. And my standard deviation, or my variance, is equal to the summation of x squared times p of x, I think, minus mu squared, isn't it? I keep wanting to put it over a denominator. And the standard deviation is equal to the square root of the variance. So you'll have to check my memory on my formulas. I think that's right. So let's go back to the handy dandy, and I'll just go over here and I'll go, I don't like that, so I'm going to put there we go, and I'm going to make sure that's bold. Well, first of all, OCD, there we go, and I'll take this one and make it bold, underlined, and centered. So this is x. Well, so much for that idea. Center. There we go. And this is p of x. And this is going to be x times p of x. Of course, you would do this on your calculator. You would just hit second, or you would hit stats, then go over to calculate after you punched them in, and hit first variable statistic, L1 and L2, and then you would look at the mean x bar and sigma x, I think it would be in that. So I'm going to say equals this times this, and copy that down, and then copy this over, and there is my mean. 6.75. 6.75 is my mean. So let's go ahead and find the variance. So this is going to be x squared equals x raised to the second power, raised to the second power. Copy that down. And then x squared times p of x. So that's going to be equal to this guy times p of x. And copy that down and do a sum, Control C, Control V, and minus, so my variance, I don't want to turn that green. Okay, my variance, I'll just put variance right here. variance is equal to, and that's going to be equal to this guy minus parentheses the mean raised to the second power, and that's the variance, and the standard deviation is equal to this raised to the 1/2 power. Okay, write 16.88. So 6.75 mu is equal to 6.75, and my variance is equal to 33.75, and my standard deviation is equal to 16.88. Now let's go back to the question. And while we're at it, I'm going to go ahead and graph this. So go ahead and draw a picture of the graph so we'll have it. Insert. And you can do this on your calculator. You just got to make sure you turn the stat plot on, as I've shown you before. And always use the scatter plot. Alright, so it's a little bit skewed left because most of the data is on the right hand side, this be in the middle. Okay? Most of the data is on the right hand side, so it's skewed left. Write that down and draw a little picture of it. I'll do that too. So it looks like it's on the bottom, and then it goes up like that. So it's a little bit skewed left. I'm just writing it down so I'll have it. Okay. Oh, I accidentally threw it up on my TV screen. Hold on a minute. Let me get this off of here. I accidentally threw it on my TV screen. There we go. Alright, so get rid of that and round to 2 decimal places. So mu is equal to 6.75. We feel good about ourselves. And the standard deviation is 16.88. Well, I'm just going to hit it again because I thought I did everything right. Whoa, no. That's not right.
Priority 1 message coming in on
1.3? Okay, let's look at that. Did y'all get 1.3? What did y'all get? Anybody, did y'all do it?
I'm still getting all the numbers together.
Okay, let me go back and check mine. Miss Carver, jump in if you got 1.3. I got 1.3. Okay, yeah, but that's the next part. I don't understand. I've done something wrong because I believe I got the right standard deviation yesterday. Let me go back to my... Hold on a second. Yeah, I'm making sure I did the x squared times p of x. Yeah. Let me go back and check my math. X squared times p of x equals x squared times p of x. I'm going to copy that down just to make sure. All right, 8 times, or 64 times 0.22. Well, 10% of 64, that'd be 12, yeah. All right, 81 times 10 cent would be 8.1, so that's about right. I'm just checking numbers. 16, 3% of 16 would be 1.6. 0.16 be 0.48. Yeah, that's about right. So that looks right. Let me add them up again. Make sure I did that right. 47. So that means I've done something wrong with my... Okay, so equals... Let me rewrite it. Variance is equal to this number minus parentheses this number raised to the second power, close parentheses. Whoa, we did something different there. No, wait a minute. Equals this number, 47, minus parentheses this number raised to the second power. Okay, now I'm getting something totally way off. Equals this number raised to the 0.5 power. Okay, I have no idea what I did wrong now, but there's the answer, 1.3. Okay, great, we got it. I don't know what I did wrong, but as you can see, I knew something was wrong. And you would see it with the MPQ. We're going to do that next. So the next, they're telling you to do MPQ, and that is a quick way to find it, to find the mean and standard deviation. So I'm going to go back to that, and I'm just going to do that with the calculator. I mean, you don't have to, really. Well, you do with 9 times 0.75. So they want you to compute mean NP. So that's 9 times 0.75. So 9 times 0.75. That's equal to 6.75. So 6.75. And then the mean, the standard deviation is going to be equal to NPQ square root. So take NP, which is 6.75, and multiply by 0.25, which is Q. And there's your variance, 1.6875. Raise that to the 0.5 power. And you should get 1.3. Now, the reason I like this question is I just went over 4. I just went over 4. There's the fourth one. Where's skewed right? B? Skewed left. There's 4 test questions right there. That's why I like this question. The binomial distribution is skewed left. Dadgum. There's 4 questions right there that I would test you on, but I will not make you do 9. Okay? So that's a good homework question. Good test question. 4 good test questions. All right, so let's go back to the homework and do that 7.2. This one came in Wednesday, so 7.2, 7/3. First of all, is it a test question? If it's 7.2, probably is. Yep, although I don't like it because it's got, well, again, we got 4 test questions instead of 1. This is a homework question, but it has 4 test questions. All right, so I'm going to go ahead and I'm going to draw 4 small, I'm going to do 4 small bell curves. And while y'all are drawing yours, I'm going to be drawing mine. Wonder if y'all Googled and printed y'all's off yet. I tell you, it makes a difference. I need to do it because I'm getting tired of drawing these that plain things. right, so I'm going to write mine at the top. I'm going to write mine on the top. Let's see. All these are to the right. Okay, so right tail. These are right tail tests with your calculator, your newer calculators. So Z is equal to 0.08.
You got a message there, Hubert.
I'm sorry, what?
You got a message.
Okay. If we aren't doing it on Excel, how would we know what the curve looks like? Put all coordinates in. Okay, after you put all the coordinates in, hold on, negative 1.35. Go ahead and finish writing this one. Z is equal to negative 0.71, and Z is equal to negative 0.54. All right. I was showing you that I'm not going to type in all those answers, but you know what it looks like, so you can check it after you type them in. If you've typed in all your answers, I mean all your probabilities, I'm going to make an example. Zoom. I mean, not Zoom. I'm sorry. Stat. Where's stat? Second quit. Stat. Edit. Hit enter. And there's your spreadsheet. Put those in. Well, that's good enough. It looks like that's it. I must have done it yesterday. Is that the same numbers? Do they look like the same numbers? That 3033 does. 3033. Okay, y'all not gonna. It looks like the same numbers.
Yeah, it looks the same.
Okay, here's what you do. You hit second. Y is equal. Look above. It says stat plot. That's what you're doing. You're stat plotting. Make sure you turn it on. So hit enter and hit enter on on. And now you just hit graph right here. Graph. Now if you don't see it good enough, which on your calculator it may be too zoomed back, hit zoom. And I think it's 9, stat. There it is. Isn't that nice? All right, let me know how you did, Miss Carver. I need to refill vodka. You got it? Good. All right, now let's get back to our handy dandy drawings. So here we go. First I'm going to draw it, and I'm going to give some kind of eyeball with the empirical rule. So Z is equal to 0.08. So 0.08, that's like 8 cents. That's like positive 8 cents. And this is $1. Okay, so 8 cents would be right here. Now I want somebody to tell me what the significance is about that line being right there that you know of using the empirical rule. What do you know without a doubt using the empirical rule about that number? Remember, you need it to the right. What do you know about this area? You don't have to say a number. You just have to tell me what you know using the empirical rule. Come on, spit it out. Good. Close to 50%. Is it 50% or less than 50%? I think y'all would agree that since it is not touching, it is less than 50%. So that means I'm going to say 0.4990. And I'm going to put a squiggly and a dot. So by the empirical rule, I think it's going to be around 0.4990. I have no earthly idea. But I know by the empirical rule it's going to be close. 0.08. Now, just for giggles and for people that have older calculators, I'm going to take a green pen and I'm going to do the complement. The complement is over here. And it's going to be more So I'm going to say it's going to be 0.5010. 0.5010. And that's a squiggly with a dot, meaning I'm guessing. Now, if you have an older calculator, you need to go from -9999 normal CDF to 0.08. If you've got a newer calculator, then you would just do right tail. This is a right. All these are right tail tests because it's asking for the area to the right. So you would type in from 0.08 to 9999 because you're reading this side. So I don't care which one you use, but I'm going to pull up the handy dandy calculator now. And I'm going to type in clear. I'm going to make this bigger for you since I can't pull up both. I can pull up both, but it will just blink. It'll go from one, toggle from one to the other. Oh well. Anyway, so second bars, normal CDF, or is it normal PDF? Which one do I use? I think it's CDF. And my lower, if I've got an older calculator, it's already, that's -99999. So upper would be 0.08. And paste. And enter. Now, if you got an older calculator, you got the real area in green is, hold on, I'm trying to, there. The real area in green is 0.5319. So if you've got an older calculator, you're going to have to do 1 minus 0.5319. So over here, you've got to do, the area under this curve is 1. So for this area, you've got to do 1 minus 0.5319. And when you do that, you get the answer. So I'm going to do 1 minus second negative, enter. So if you've got an older calculator, your answer is 0.4681. 0.4681. Now, if you've got a newer calculator, you'd hit second, bars, normal CDF, and you would type in 0.08 to 9999. And hit paste. Okay, there goes another explosion. If I just go off the air right quick, y'all call 911, okay? 0.4681. And again, that's what we got, 0.4681. So if you got a new calculator, you go from from 0.08 to 9999. If you have an older calculator, you go from -9999 to 0.08 and then subtract that from 1. Okay, either way, you're going to get the same answer. All right, so the next one. The next one is, and we'll do this one in yellow and purple. Big old Minnesota Vikings. All right, so 1.35. Negative 1.35, there's -1. And 1.35, that's 1.5. 1.35 be a little bit over half of that. So there's -1.35. They want the purple area. Now, what can you tell me about that purple area? Well, heck, this is it. Excuse me. This is 84% right here. All of this to the right is 84% because this is 50 and this is 34. So you know to this point right here is 84%. Now 1.35 is about a third. Okay, that's about a third. 0.35 is about a third of 13. 3 will go into 13 4 times. So this is 4. So I'm going to say it's about 0.8800. And that's rough with a little dot over it. That's rough. So that means this side, the yellow side, is around about 0.1200. 0.1200. Now that's by the empirical rule. Now, if you've got an old calculator, negative 9999 to negative 1.35, and then take that away from 1. If you've got a newer calculator, 1.35 negative to 9999, then you don't have to do that. So I'm going to let y'all do that. We're going to try to go through all 4 of these, so don't have a fit because I don't have a class and y'all don't have a class, so we can finish this problem. Okay? Where am I going? What does this say? Okay. Are y'all got anywhere pushing, go anywhere like in the next 5 or 10 minutes? Y'all okay?
I'm good.
Okay, how about you, Miss Carver? You okay? Okay, I'm going to do something kind of out of the ordinary here. Just bear with me a minute. I'm multitasking. Somebody's having a problem. P-A-R-N-E-T. So just bear with me a second. She's going to come all in talking loud because she don't know she's coming in a class. So give her... Come on, answer the phone, Andrea. She's having a problem with Skype. Another teacher. And this is one of those teachers that actually asks for advice. They don't try to figure it out themselves. That's kind of a good way to do things. I guess she's not going to answer. Okay, well, we'll keep going. There she is. Andrea, are you there? Because I'm in class right now. But are you there? She's not there. Andrea, are you there? Okay, she can come in. Tried to Skype you. If you're going to Skype, so if you're going to text somebody and say, can you Skype, at least be ready to Skype, you know? I don't know why these students and teachers do it. I'm going to do it one more time. B-A-R-N-E-T. I'll try it one more time. Okay, so the next one is negative. Oh, did we do the last one? We didn't do the last one. So I'm going to make this small. And we're going to do second bars and normal CDF. And we're going to do from, I'm going to do, Andrea, are you there?
I'm here.
Okay, I'm in a class right now, so they don't have anywhere to go. So what I'm going to do is I'm going to pull this in so you can see my, hold on just a second. I'm going to pull this and bring this in. Okay, do you see my Skype desktop right there?
Your calculator and stuff? Oh, yeah.
You see it? Okay, there might be a little delay.
Yes.
You see this little gearbox right here? That little gear says options.
Yes.
Click on that. And then these are the two things right here, audio and video. Audio and video. Video, when you click on it, it's going to ask you right here, where do you want the video? Right there. And now you can use your Ziggy, you can use that, but I just use what's in the computer. Okay? Then when you present, and there's your audio right there. And when you present, you present desktop. And when you present desktop,
Yeah.
all you got to do is hit the visualizer and maximize it. And they see, right now my students see what you see, and that's the visualizer. And then I make that small, and then they can see the calculator. They see whatever's on the screen. And of course, I can also enable my video, which is used on the laptop. So now you should be able to see my video, which I turn my video off during class, so it'll decrease the bandwidth. So does that answer your question?
You turn yourself off during class?
Yes, my video. I just hit the, hold on.
The camera button?
I hit the bottom right here. I hit that right there, and I turn my video off.
Okay.
So now all you should see, and that's why you need to have a second monitor, like a TV screen, so you can keep all this situated. I keep my conversation, my Skype conversation on the TV screen, and therefore I know that whatever's on my computer screen, they see. Okay?
Oh, okay.
All right.
Thank you.
All right, let me know. I've got to take Walt to his mother's, and then I'll be back for my 12:20. So if you need questions, call me back or talk to me after the meeting.
Okay, I will.
All right, talk to you later. Thanks.
Thank you.
Mm-hmm. Okay, sorry about that. Thank y'all for being patient. All right, so I'm going to type in 0.08, or let's see, 1.35. I'm going to do the older calculator. So I'm going to go negative 9999 to negative 1.35. And enter, and that's going to give me, enter, I said, I forgot, I said 0.1200, comes out to be right at 9%, so I was a little bit off. So that's equal to 0.0885. 0.0885 is the actual answer for the left. And then I'm going to subtract that 1 minus inverse or second answer. And that leaves the right side in purple to be 0.9115. 0.9115. And I said 0.88, so I was a little bit off. Okay, so that's that one. The next one says to the right of negative 0.71. Negative 0.71 is right in there. They're wanting to know the right-hand side, so I know that's going to be close to 84%. I'm going to say 83%. Notice my approximate, which means I'm doing it by the empirical rule. And that means that this side, on the left-hand side, is going to be 0.1700, approximately. So now I take my handy dandy calculator and I pull it in, and I do, and you can just hit, since that one is the last one right there, I'm just going to say second, enter, second, enter, and there's that. So I'm just going to type in right here 0 right there. I'm just going to use 0 as a placeholder, and then 7-1, and hit enter. That's 0.9564. 0.9564. Wait a minute, that's not right. Negative. Oh, that says 1.71. Okay, let me fix that. It must have inserted. Sorry. So I'm going to take that 0, or that should be negative. So negative 0. There. Try that now. And enter. Now, what saved me right there? Dadgum empirical rule saved me, because I knew something was wrong, because my empirical rule said 0.19 or 0.17. And that comes out to be 0.2389. 0.2389 on the left-hand side. 0.2389 on the left-hand side. And on the right-hand side, we're going to do 1 minus second answer. And that's going to be 0.7611. And again, I said 83%. But you got to remember, the empirical rule is by eyesight. And you can't get it down to details that's what the z-scores are for. And the last one is negative 0.54. So negative 0.54, we'll use a different color. 0.54, there's 0.5. Negative 0.54 would be to the left of it. So this is negative 0.54. Well, you know, half of 34 is 17. So that's 50 plus 17. And it's going to be a little bit, let's see, 50 to 67. So I'm going to say it's probably going to be around 68, because it's a little bit above halfway. So I'm going to say approximately 0.6800. So therefore, the left-hand side, I'm going to use peach. Left-hand side, I love my Sharpies. Left-hand side, they smell good, is going to be 0.3200 approximate. So let's check it. I'm going to do the right-hand side this time. So I'm going to take my handy-dandy calculator, and I'm going to go second bars, normal CDF, negative 0.54, 9999, and paste. And paste. 0.7054. 0.7054. 0.7054. And of course, 1 minus inverse answer. If you've got an older calculator, then you would have 0.2946 on the left-hand side, and you subtract that from 1. 0.2946. And when I put it in a rectangle or a circle, that means that's the actual answer. So your graphs It'll look like that. Messy, but it'll do for a test if you're working on a test. So that is 2 good questions. We went over 8 test questions today. 9 if you count that little one that asked for skewed left or skewed right. So we went over 8 to 9 test questions today. Okay, y'all have any questions? All right, how do y'all feel for the test? Have y'all got your homework pretty much finished?
Yeah, I got my homework done.
Okay, good. And yeah, she does too. So y'all can just have a good weekend, and we'll go over the test Monday, and that'll be it. You can take the test, and you can go ahead and take the test now if you want to. But we're going to cover the test Monday, and that way everybody will be on the same sheet of music. Okay?
We're going to back it up to Wednesday?
The test, yes, probably.
Okay.
Because I'm going to go over it Monday. So that'll give everybody 3 days to do it if you count Monday afternoon. All right. Y'all have a good weekend, and I'll see y'all Monday.